So getting into the immune system and how it pertains to infectious disease, I like to always zoom out to begin with. So we have this system in our body called the immune system, and it has many roles to play. But one of the chief roles is to protect us against microbes that are either part of our internal environment or microbes that are part of our external environment from, I guess, entering into our tissues and establishing themselves in a way that is destructive to our tissues, that causes harm. And as far as any sort of animal human history goes, this type of relationship exists in all creatures. And it is something that we very much need to have the capacity to protect against microbes in order to live. If we did not have an immune system, then infectious microbes would, basically take us over as a host, and we would succumb to that at some point, depending on our vitality and strength. And so what our immune system does is it both identifies the presence of a foreign compound and helps us determine whether it's friendly or unfriendly. And then if it's determined that it is unfriendly, it activates a whole host of mechanisms to neutralize and or destroy the unfriendly compound and prevent either spread of that pathogen or certainly reducing the existing spread that's there. And so the theory of how that happens, how we get infection, is there's actually two competing theories that we understand, and they're pretty old theories, but they kind of remain true to this day. And one of the theories is the one that most of us are familiar with in our culture, in our main conventional medical paradigm, which is called the microbial theory. And so the microbial theory of how infectious disease occurs is that in order to create infection, you need to have a microbe. And when that microbe is present, in other words, an exposure to a microbe, then that leads to infection. And so the way to prevent infection is to prevent exposure to the microbe. And the way to treat infection is to kill the microbe. So, the big kind of salient topic for our present moment that we're in the world is the coronavirus pandemic. And so you look at the public health kind of paradigm here, and it's very similar to that line of thinking, right? All of our public health measures are designed to prevent exposure from the coronavirus, right? So we've been told to wear masks. We've been told to wash our hands. We've been told to avoid being in large groups. And when we are with people, to distance ourselves so that droplets of infective saliva or even aerosolized particles don't go into our system. And so that really mirrors that preventive model of not being exposed to a pathogen. The treatment side is, kind of interesting for viruses in conventional medicine. They don't have a lot of good treatments for them. So to kill viruses, there's very few medications that really are able to do so, although there are some antiviral drugs that have been utilized and have been shown in this case to, reduce the severity and duration of the infection. And so some of those tools are being used, but mostly it's about keeping other systems functioning while the body itself works on clearing the virus. When we talk about other pathogens like bacteria and fungus, conventional medicine tends to have more usable tools, antifungals, antibiotics that can actually go in and inhibit and then destroy those microbes. But our body, as we'll talk about in a few minutes, has many intelligent ways to accomplish this, and it indeed does so. Every single day, every single moment, as we're speaking, our body is immunologically neutralizing and destroying pathogens that we are either breathing in, eating, having exposed to our skin, and etc. So that is the microbial theory of disease, which is the prominent model of infectious disease our healthcare system uses. The other theory that is very kind of, I think, my personal opinion, much truer and comprehensive, and carries a tremendous amount of weight in terms of how I approach infectious disease, is the terrain theory. And so the terrain theory states very simply that if you are dealing with microbes, that in order to have an infection, you need both exposure, your body needs to be exposed to the pathogen, but your terrain or your system, your body, needs to be susceptible to that organism in order to host an infection, to become infected, to become ill. And so that second part, the terrain, the condition of the body, is incredibly important in determining if you get ill when you're exposed to a pathogen or if you do not. And that is something, in my opinion, again, harkening back to the pandemic we're still in the midst of, has been tragically underappreciated, underdiscussed, and shamefully underempowered to our society as something to really take incredible wisdom from, in terms of how we take care of infectious disease. And when I say terrain, in this model of infectious disease, I think a really good, there's a couple of good metaphors I want to describe. One is not a metaphor, but it's more of a circumstance. Is, I'm sure we've all been to social gatherings, whether it's family or friends, where there was either, microbes in the food and people got food poisoning, or someone was really sick at the party and coughing and, sneezing up a storm. And what you end up finding is that, well, in both of those situations, even though everyone eats the food or everyone is exposed to these pathogens flying through the air, only a percentage or a proportion of the people get sick. And if it's true that the exposure is there for everybody, then why is it that not everybody gets sick? That would reinforce the microbial theory model. So my argument in that case is the reason not everyone gets sick is because the other variable, not the exposure, but the terrain or the soil of the individual, the vulnerability or susceptibility, is different. And those who are not susceptible to the microbe are not going to succumb to creating an illness. And so that's really important, as just an example we've all lived into and experienced ourselves. Furthermore, to illustrate this concept, I think it's a good metaphor to use my trash can metaphor. And everyone knows when you take out your trash and it's hot out and it's been sitting there and middle of summer and it's got a bunch of leftover food and meat products, that you might get a bunch of flies, you might get a bunch of bees buzzing around your trash can. So in this case, the metaphor is the bees and the flies are the microbes, and the trash is the terrain of the individual. So there's two ways, if you want to get rid of the microbes, you can go about it. You can get some insecticide and you can, douse the trash can and the air around it and knock those bugs out. At least temporarily, that will get rid of the flies. Or I think more elegantly and more permanently, you can get the trash picked up. You can get rid of it. And if you don't have any trash, there's no reason for the bugs or the flies to be accumulating on it. And so that's essentially where we interface with the terrain theory, is we recognize that we have the capacity to influence our terrain. And there's some really fundamental elements of determining forces of health that go into the strength and vibrancy of our terrain. And I'm going to spend a good bit of time talking about those forces and those pillars, because to me, they're some of the most important ways we can be empowered in a model of prevention, meaning, hey, regardless of whether or not we get exposed to microbes, if we do get exposed, if we are not susceptible because we're preventively strengthening our terrain, we're taking out the trash, we are, filling the cracks in the pavement so no weeds can sprout, whatever metaphor you want to use, then we are not going to become ill. We're not going to be acutely sick. And so that's really, as a naturopathic physician who really values the philosophy of preventive measures in the care of health, the most important work to consider. Now, later in the talk, I will talk about what tools do we have available to us when we actually are sick. But if anyone on this call, wants to volunteer and say they like feeling sick and being sick, please do so. But I know I'm, for one, never going to desire to be sick. I would much prefer to be in full health and not be run down with all the things our body does when we get sick. So that divergence, I think, is pretty important to recognize, those two different competing theories. And unfortunately, again, when we get medical care from our physicians, our conventional providers, these principles of prevention and modulation of the terrain is not really prominent because we have a disease-based model of health, right? Our healthcare system looks to intervene once illness is present, rather than as a way of building more robust vitality, health, and reduction of susceptibility, so we don't have to encounter the disease process at all. So moving forward from that, I think it's pretty important to just take a little segue here and talk about, how does our immune system work? What are the forces that it employs to prevent infections from developing in our body? And then if infections do develop, take care of them. And so there are two parts to our immune system that we classically, categorize in immunology. There is a part called the innate immune system and another part called the adaptive immune system. And the innate immune system is one that is constantly engaging with pathogens, and it's a very non-specific form of immunity, meaning that most of the components of our innate immune system are broadly neutralizing and destructive to all forms or many forms of pathogens. Whereas the adaptive immune system is actually a more delayed response part of our immune system that's tuned specifically into the exact signature and unique structure of a singular virus, a singular fungus, a singular bacteria. So when we're talking about the ways to be preventive in naturopathic medicine, we're really talking about this innate immune system, right? That's what we have the capacity to really enhance and optimize. And so turns out there's a lot of parts to that immune function. So on a very basic level, let me talk about some of them. Our skin is part of our innate immune system. It's a barrier. It does not let much through. And that's very advantageous if we're constantly getting exposed to pathogens in the air and when we touch water and substances. Our skin even has on top of it these molecules called defensins and different enzymatic type structures that are actually bacterial, viral, and fungal static. that actually will prevent adherence and actually digest their cell walls. Our mucous membranes are our mouth, our ears, vaginal tissue, gut lining. There's a whole host of compounds in these secretions that are non-specific. We have things called macrocytes. We have things called dendritic cells. Basically, these different constituents of what we all have heard the term white blood cells. Well, there are plenty of different types of white blood cells that are responsible for eliciting basically actions that destroy the cellular walls and the life of pathogens. And so these are getting secreted into all of these tissues really regularly and are trying to catch microbes as they land on our mucous membranes from penetrating into our tissues. They also all exist in the blood, by the way. And then we also have some other really important protections. One of our big protections actually is the acid in our stomach. The pH of our stomach is 1 to 2, which is incredibly acidic. It basically is so acidic that it will digest an entire tooth in less than 24 hours. Very hostile place for microbes to survive. So it's pretty difficult if we have good stomach acid for microbes to make it past our stomach into our intestines where it's easier to penetrate our tissues. So those are just to name a few, some of the more innate components of our immune system. And it helps explain why, even as we're all talking, each of you sitting in whatever room you are, breathing whatever air you are, drinking whatever fluids, the reality is there are millions and millions of viruses and bacteria and fungal spores and parasites even all around you, all around us always. So sometimes I think it's a bit of a cognitive dissonance to talk about things like the coronavirus or infections and have this belief and kind of thought in our head that we have to be on the guard for this infectious compound that's so scary and dangerous. And so we need to do all these extreme, protective measures to prevent exposure. Well, guess what? Right now, we're all being exposed continuously, breathing in literally hundreds and thousands and probably millions of microbes. And our immune system, the innate part of our immune system, is making sure that those microbes don't set up shop in our tissue and become an infection. So again, as an argument to the terrain part, what really causes infection, in my opinion, is not some inherent error in our immune system's capacity to kill microbes. It's when we alter some of the forces of how that immune system works to not be as vigorous in its ability to clear those pathogens. However, sometimes the innate immune system, because maybe our guard is down, some of those mechanisms fail, and a pathogen, whether it's a virus or a bacteria, might get established and set up shop and start replicating and reproducing. As it replicates and reproduces, it starts to cause issues in our tissue because it sequesters resources and our immune system marshals a response. And kind of then we're in a place where the innate immune system is, if not overwhelmed, not able to sufficiently address the infectious process that is spreading. And so our body has elegantly created another mechanism with which to deal with this, which is the adaptive part of our immune system. So the adaptive immune system is based on this concept that we have this whole elegant structure of communication in our body that's called the lymphatic system, that has these nodes in places where all the immune cells go to talk to each other and to kind of create and germinate different types of cells that are much more efficient at killing off microbes that are very microbe specific. And you've probably heard these terms, especially in recent days with vaccine conversation. They're called antibodies. They're called killer T presenting cells. They're called killer lymphocytes. They're these forms of immune cells, white blood cells, that are microbe specific, and that as our body samples the microbe that is building an infection, will go build a unique immune response to that microbe. And it happens kind of in these lymph nodes and these little patches all throughout our body where these presentation and information exchanges happen. And then once those cells are manufactured, they're sent back to the site of infection, where then they clear the infectious process, kill those pathogens. And so this process, unfortunately, doesn't happen instantaneously. It takes a little bit of time. It tends to take actually a few days to start making these pathogen-specific immune cells. And so that's why we see what's called an incubation period in many infections that people develop, because from the time of your exposure in the seeding of that infection, it takes a few days to grow the infection, but then it takes also some time to start to build those immune cells unique to those compounds or to those pathogens. So we will tend to, get sick a few days after exposure, and then it will tend to take a little bit of time for that immune process to complete its work. After which we're fine and we're back to our, more robust state of vitality, and we have cleared the acute infection, no matter what tissue this is in. And so it's a nice place to do a little step aside to talk about conventional medicine's kind of use of vaccination as a means of what we might call prevention in the conventional fashion for acute infectious disease. And that's the idea that we can create in a lab a compound that looks like, say, a virus or a bacteria that's very specific, like the COVID-19 virus. And we can introduce that compound into someone's tissue so that it causes that adaptive immune response to happen, but it doesn't cause it in such a way that you actually bring with it the full-blown infection. You're not actually introducing the virus itself, you're introducing a piece of that virus, or a protein compound of that virus. In this case, it's a spike protein for the coronavirus. And that in doing so, your immune system develops this adaptive response and has it stored away so that in the future, when you get exposed to the pathogen, then rather than having to, if you set up an infection, wait those 3 or 4 days to develop that adaptive response, your immune system kicks in immediately and it starts cranking out antibodies and killer T cells and kind of nips that infection in the bud. And so that's the whole principle and science of vaccines. And in our, society's history, vaccines have been invaluable in combating some really nasty infectious diseases in our history and saving a lot of life. Now, it would be seemingly the perfect medicine or tool if there was no downside to vaccines. And I'm not going to weigh into this water too much because it's not really what the main thrust of this conversation is. But when you put a vaccine in the body, especially when you inject it and you add a bunch of compounds in it called adjuvants to really get your immune system to pick up on the injection and kind of build out the adaptive response, there are going to be a subset of individuals who have an undesired response to that input, even a response that can do significant harm. And so I think what I would say, for example, about the coronavirus vaccine and my personal viewpoint on it is that there is no doubt that it will reduce the sickness and probably the spread of viruses, of the coronavirus particularly, because of eliciting that adaptive response. But there's also no doubt in my mind that a subset of people will become ill, some of them very mildly ill and very transiently, and some of them very significantly ill for a prolonged period of time, because the immune response is too vigorous to the vaccine. And I think that's an important thing for us all to understand, is that when we get acutely ill with any, whether it's taking a vaccine or whether it's an infectious pathogen, what we are feeling when we are ill is our immune system's response to the pathogen. Say that again. When we are feeling ill from an acute infection, it is from our immune system's response to trying to clear the infection. And so those symptoms we characterize: sore throat, fever, runny nose, cough with phlegm, burning, stinging, all the things we experience, heat, swelling, those are our immune cells trying to take care of, address, and clear the pathogen. So it's the same story that with a vaccine, those things can all happen and create a undesired response that can do harm in our body. Many of the long-term consequences, both of vaccines as well as pathogens that infect us, is the immune system's response in our body and how it damages tissue. Sometimes for the long term, like you're seeing the COVID patients having, long-standing heart dysregulation, lung dysregulation. That's because our immune system is overreacting to the pathogen, or in trying to clear it, is damaging tissue. So just want to make that clear, and to say why I have a nuanced kind of perspective about vaccination and it being a panacea for, solving infectious disease. Because one of my core philosophies and tenets of my practice is using the lowest force means possible and using therapeutics that first do no harm. And it is true, and I don't think any scientist would argue with you, that vaccines have the potential to do harm, that it is just not, being on the public health agenda, it is not being named, acknowledged, and educated nearly to the degree that the other side of the coin is, which is the protective, beneficial measures of creating adaptive immunity to the specific virus or microbe, which also is helpful and by no means is something to dismiss as a valid tool. So just wanted to say that, and it's very salient to where we are time-wise in what's happening with a very big, society-wide thing. I feel like what I'd like to transition to is a much more fundamental, broad, sweeping conversation of all of the forces related to terrain that influence our susceptibility to what happens when we're exposed to microbes, which we inevitably are going to be. And so when we look at our immune system, what are the primary forces that kind of influence its vigor, vitality? Well, one thing is pretty obvious that we can't neglect to mention, which is our genetics, right? We all have innate susceptibilities that are inherited. And that's the same with diseases like heart disease or asthma or eczema. It's really like anything related to our health that we have inherent susceptibilities. We could call that on some level genetic, but predispositions that make us more or less likely to kind of manifest or to develop an imbalance or limitation in our health. And that is true of the immune system and infections as well. And so that's always going to be a possibility. However, our activating that vulnerable expression, whether it's heart disease or chronic ear infections or chronic urinary tract infections, has to do with what environmental forces activate those vulnerabilities. So we still come back to this concept of the terrain of the organism, the soil of the organism. So what is it that influences that? And what are the things that we can be empowered to pay attention to and to be working with on our day-to-day lives in order to reduce our susceptibility? And if we're not susceptible, even with exposure, we are not going to create infection. And so one of the really core fundamental ones is, we talked about microbes liking to land on mucous membranes. Well, the mucous membranes, turns out, in order to have them more vigorous and slippery so that those microbes can't land and stick, they need to be really well hydrated. To make mucous membranes nice and hydrated, guess what we have to do? We have to hydrate. And that's a really fundamental, simple thing that we forget about with infectious disease is adequate hydration is really important. And so using, half your body weight in water intake a day and not using dehydrating substances like coffee and sugary drinks and alcohol really can help our hydration status. And I usually like to suggest half your body weight in ounces as a good baseline for hydration daily. Other ways you can directly affect the mucous membranes is you can do saltwater gargles, you can do steam inhalations or humidifiers. Those are ways to do at least the airways, those mucous membranes, to bring more slipperiness and hydration to them. So those can be preventive practices. Another system that is so crucial for our susceptibility is the circulatory system and the lymphatic system. And these things are side-by-side organ systems in our body. So in all this discussion, we're talking about microbes landing on different surfaces and then building infection, but that our immune system shows up and identifies the infection and then does not allow that infection to spread or grow. Well, in order for our immune system to show up and be there, what do we got to do? We have to have circulation working in our body. And, on a very basic level, our main tool for circulation is this big muscle we have called our heart. It's a big pump. So that pumping action distributes blood through all of our tissues, which includes all the immune cells, and the immune cells spill out into the tissues and address any process going on. And then as that blood returns to the heart, it picks up toxins, debris, and then moves it back to the metabolic organs to be cleared from the body. So it's twofold. It's delivering nutrients, delivering oxygen, it's delivering immune cells, but it's also picking up all the trash and bringing the trash back to the heart and then other organs of elimination to be disposed of. So if that organ system, the blood and the circulatory and lymphatic system, are sluggish, or if it's kinked up, then we have higher susceptibility. And both from the standpoint of not having the immune cells there and have more trash and toxins and waste products flying around. So one of the biggest predisposers to infection is sedentary living. Our species is exquisitely sedentary as a whole as compared to ancestrally, when we spent the most of our waking life, moving and walking around and being in nature, foraging our food. So exercise is one of the most powerful, profound ways to prevent infectious disease. Another thing that I talk about all the time, and I'm a huge fan of, is contrast hot and cold hydrotherapy. Hydrotherapy meaning water therapy. And this is the principle that when you apply alternating hot and cold to the skin surface, you essentially get a pumping action at the tissue level of those blood vessels that basically pumps your blood as a tool of circulation. And so I tell people, it is such a great practice for every shower you take to end it on a cold rinse, to start at your periphery, move toward your heart for about 30 to 60 seconds, milking that blood back toward your heart. If you want to make that more vigorous, you can do it several times during your shower, back and forth. And the more the contrast in temperature, the more therapeutic the process. Excellent way to address more vigorous circulation. And there's all sorts of research on this, dramatically increasing white blood cell levels in the bloodstream. So really good science there too. You can also do other gentler ways to move the blood and lymph. Dry skin brushing with a horsehair brush is really great. Body work, getting massage therapy, having that more manual action of moving the blood and lymph can be very good for this principle as well. So, but on a more fundamental level, exercise, right? Let's move our bodies every day, for at least an hour, this is a great way to increase circulation, which is one of our most powerful tools for immune promotion. Now, another thing that's really fundamental, simple but powerful, adequate sleep and rest. I don't know how many times in my life I could directly relate to getting sick after a period where I burned the candle at both ends and I didn't sleep enough for consecutive days. And my body's immune system, which relies on that restorative, restful time to regenerate and repair and recuperate, did not get that regenerative time and became weakened and less vigorous. And therefore, I began to host an infection. It's also why when you get sick, one of the most important principles is rest more and sleep more, because that regenerative time is really important to give your immune system the resources it needs to address infection. So many Americans either have sleep issues or they don't value sleep enough. And this is a big issue, making our terrain more susceptible to infection. And I think if you kind of turn the other side of the coin of that, we've got to talk about stress. And in one way, I would say that probably this is one of the top two factors increasing our susceptibility to infection from the terrain theory perspective. We know the physiology of stress really, really well. We know that when our body is manifesting a stress response, one of its classic actions is to deactivate our innate immune system and to some degree our adaptive immune system. So one thing people could appreciate is like when they've had a big test or a big deadline, that they end up getting sick right after that test or deadline. And, it's like, that happens. And well, what's actually happening there is while you're stressed out, studying, pushing for the deadline, not sleeping enough, you're actually starting to seed infection in your body that's starting to grow. But because your immune system's so shut down, it's not causing the symptomatic responses. Remember, because the symptoms of an illness are actually our body's, immune responses. So then when you finish the test or get through the deadline, everything wakes back up and activates and you get sick. Because your body's then addressing the pathogen. So that phenomenon of stress, which of course, this is a factor of our minds, right? Stress there are some physical, literal stressors that activate the stress response in our body, but most of it is our minds cueing over perceived dangers or irresolutions about our life and world around us. And so this is like, relationship stress, work stress, rumination about the future, rumination about the past, all of the ways that our minds hijack our body into not being present and being in a safe, centered, present space. So that's a very expansive conversation that we individually have with each patient at our clinic in regards to how stress is in their lives, how it lives in their body, how people relate to it, how it's affecting their health and well-being. And one of the main ways that pertains to how we can witness that is how it affects immune system, which is in usually a quite suppressive manner. So very important. And also, again, I'm just going to draw the pandemic into this a little bit because it's so present and relevant, is that all of the stress that we have all been feeling from being told to isolate, to not have physical touch, to not do the things we love and connect to many of the joys that are, endemic to being human, it has also incredibly amplified our state of stress and isolation and loneliness, which makes our immune systems more susceptible and vulnerable to infectious disease. So there's quite a contradiction there that is tragic to me, and that as a terrain theory kind of devotee is really discouraged by that phenomenon. Enough said there. So the kind of other two areas I want to talk about in terms of prevention, and then we'll move on to some treatments, is this part of our terrain that has to do with the accumulation of toxicity in the body. So if we're saying, that essentially what gets the flies to accumulate and collect in our body, i.e. the microbes, is the trash that we're, flaunting and carrying around, then one of the best things is to get rid of toxins and debris out of our body, off of our mucous membranes and our tissues, so that there's nowhere for a microbe to thrive. And so that our immune system isn't bogged down by all that debris and toxicity that's clogging up its efficiency and vitality. Now, there's a lot of places where we accumulate toxicity, a lot of causes, but by far the number one is through our modern standard American diet, right? I mean, processed sugar, trans fried fats, really low vegetable whole food diet, high processed, low quality meat, sugars, alcohol, substances, tobacco, all of these things that, we are essentially putrefying our body's environment and making an incredibly, a ripe terrain for flies to buzz over us and land on us and take us over. And that is, again, epidemic in our society. And one of the very tangible places these toxins store is in our fat cells, which another epidemic that is, profound in our society is obesity. Obesity has all sorts of research of lowering immunity, increasing toxicity, and therefore, on that terrain level, making us more susceptible. And indeed, the people who we're seeing get really sick with COVID that are not really elderly, they are 98% obese. And I know that this is not, again, out in the public media because it doesn't benefit the broader narrative, but these are the people getting really, really sick. And so the way that we care for ourselves, the long-term care we give to ourselves proactively, preventively, has everything to do with both our susceptibility to harboring infection as well as how efficiently we clear infection. And so eating thoughtfully, eating whole foods, eating lots of fibrous vegetables, eating clean meats in small amounts, minimizing refined sugars and starches, these are really fundamental basic principles. And they have everything to do with how intelligent and vigorous our immune system is too. One of the things that this profoundly influences nutrition is our gut microbiome. We haven't discussed this, but I'll only briefly mention it. There's other lectures I have done on this topic, but essentially our microbiome, are the microbes that live in our gut, are more responsible to the intelligence and capacity of our immune system than any other single thing, because our immune system on a gut mediated level is constantly interfacing with the bugs that live in our gut. And by the way, speaking of microbes, we would not exist without the microbes that live in our guts that help us digest our food, that help kill off pathogens that get in our gut. There are trillions and trillions of organisms, actually 100 times more organisms than there are cells in our body that live in our tissues, specifically in our gut lining. They're very responsible for how savvy our immune system is at identifying and addressing pathogens that get into our mucous membranes and body. So again, when we have really poor nutrition, that balance of those microbes goes from really friendly, helpful microbes to really unfriendly, pathogens that basically make matters much worse. So it's an important little element to really recognize. Now, one last thing to point out about toxic burden in terms of the terrain and the soil is the other way that we accumulate toxicity in our body is that we don't get rid of toxins well. So let's circle back to circulation and lymphatics, right? That's sluggish. We're not going to get rid of toxins as efficiently. Other eliminatory organs are a big deal in this too. Kidneys, right? Water, hydration. If we're not drinking enough, we're not clearing toxins through our kidneys. The colon, another big elimination pathway. If we're constipated, if we're incompletely eliminating, if we're not eating enough fiber, our liver, which dumps a lot of those toxins from our body into our bowels, If that's not happening well and completely and efficiently, we're recirculating a lot of those toxins. If we're not breathing through our belly and doing good belly breathing, the air exchange that's a major toxin elimination pathway is not able to happen. If we're sedentary and not exercising, the pathogens and toxins that get sweated through our skin is not able to be achieved. So eliminatory pathways and ensuring they're working well is a huge deal. So I know I've been rapid fire talking. We actually are over our time that I was kind of shooting for. So I am going to spend just a few minutes on techniques that I have found to be really effective at addressing infectious disease. And I'm not going to get too specific into different types of infections because we don't have the time, but I am going to say a few things that hopefully is good generalized advice. Number one thing I can say about how to clear an infection from your body in the quickest manner possible is, remember, your body's going to do it on its own. Either you're going to clear it and it's going to be gone, or you're going to die. 99.999% of the time, you clear it. But what's going to help clear it faster? That's what we're after in medical interventions. Number one tool is fasting. When we stop eating, or when we simplify our nutrition, so we're eating vegetable broths with the little veggies or bone broths, we are essentially resting our digestion, which takes up half of our body's energy. When we stop eating, first, we stop potentially feeding infection. But number two, we dramatically amplify the share of resources our body gives to our innate and adaptive immune system. So even though you need to discipline yourself to eat sparingly, our body has an actually very elegant, intelligent method built into this process, which says our appetite goes away when we get sick. Very, very wise of our body, because it frees up resources for our immune system to take care of the concern. So that's a beautiful thing to do when you're ill. We already talked about resting. We already talked about removing stress. All those things are going to make your body clear pathogens more rapidly. Drinking enough water, gargling salt to keep your mucous membranes clear. However, sometimes there are some other additional compounds that really help reduce or make your immune system more robust to clear pathogens. And I cannot not mention vitamin D here because it's so important in this capacity. Very crucial vitamin for our immune system. And we can only make it by being in the sun. And most of us don't spend very much time in the sun. So taking, as an adult, around 4,000 to 5,000 units of vitamin D every day is a very wise, proactive process to make a more robust immune response. And that's usually with a meal because it's a fat-soluble vitamin. So that's one just very basic supplementation that is good for all of us. Another thing that's very effective both at virus and bacterial destruction is vitamin C. I like the ascorbates, meaning not ascorbic acid, but ascorbate is a more buffered form of vitamin C. But we can get a little bit through citrus foods. We can also take it supplementally. And because it's water soluble, I try to suggest people put it in powders and put it in their beverages and drink it throughout the day. Can be preventive at lower doses of like 1 to 3 grams, or basically to bowel tolerance up to 10 grams a day throughout the day when you have an acute infection. I also will use herbs a lot in various forms of infection, whether it's in the airways, throat, ears, or urinary tract, etc., in the gut. There are some very good antimicrobial herbs, and unlike in conventional medicine, where we really mostly only have antibacterials, antibiotics to use, we have herbs that work both on viruses and on bacteria, and they don't kill the good bugs in our gut. So in my opinion, they are infinitely better than antibiotics, which only work on a very narrow range of compounds and also create all sorts of issues in terms of the good bugs that are living in your gut that you want to keep around. So there's several formulas I really like. Golden seal, that is both bacterial and fungus and viral. I really like OSHA, which is also all of those things. I really like licorice. I really like bloodroot. I really like garlic. I really like, let's see what, I mean, there's so many, I can go on and on uh, in terms of what some of those compounds are, but those are just a few that I will mention. So there are some great compounds. There's some great minerals too. Zinc's a really good one for the immune system. Really helpful to kind of robustly increase immunity. 50 to 100 milligrams a day of zinc can be really helpful in clearing an infection and preventing an infection. So I know that I haven't got into individual specific infectious types of processes. I could go into a lot more detail, and I am going to upload the video I do tonight, which is going to have twice as much time to talk. So hopefully twice as much ground to cover. So if you're thirsty for more, tune into that on our website. And I think that for now, I am going to break off this lecture and jump into my afternoon patient care, but I appreciate you all being on this call with me and hope you enjoyed what you learned from it. So thanks so much. And I'm going to stop the recording and